Okay, today we are proving segment relationships, lesson 2.7. So there's a couple of content standards. We're using theorems again. We're going to prove theorems about lines and angles and make formal geometric, well, we're not going to really do the constructions so much today. We'll do those with this lesson though. Mathematical practices, reason abstractly and quantitatively, and construct viable arguments and critique the reasoning of others. So previously you've written algebraic and two-column proofs. Now we're going to write proofs involving segment addition and involving segment congruence. So first of all, there's the ruler postulate, and I would like for you to add this postulate to your notes. Notice that it has a lot of verbiage here, but basically it says that if one point starts at 0, the other one's going to be a positive real number. Because we're measuring distance, we're measuring length, and you cannot have a negative distance or length. Remember? Who wants to sleep on that bed with a negative length? And also today we'll be discussing the segment addition postulate. So it says that A, B, and C are collinear. Remember, they lie on the same line. If they are, then point B is between A and C only if AB plus BC equals AC. Okay, so add that to your postulate notes before you move on. Okay, example 1. They're wanting us to use the segment addition postulate, and they're wanting us to prove that given segment AB is congruent to segment CD, we are to prove that segment AC is congruent to BD. You will want to write this information down, what is given, what you're proving, and draw this diagram before you go any further, because after a little bit it's going to vanish off the page. So pause and get that done. Okay, we're going to do a two-column proof. And notice that we start with our given. Okay, segment AB is congruent to segment CD. We always start with a given. Now, because of the definition of congruent segments, we can say that they're equal to each other. The reflexive property, we can always insert this. Isn't BC equal to BC? And that'd be reflexive. It's equal to itself. So since BC is equal to BC, we can say that AB plus BC is equal to AC. Okay, AB plus BC is equal to AC, segment addition postulate. Now here's where it'd be good to have written down what you had before, because now we can say CD plus BC equals AC. We're replacing AB with CD, because previously it said AB plus BC equals AC. And we're also told on the second step that AB is equal to CD, so we're able just to substitute CD in place of AB. Now the segment addition postulate, CD plus BC equals BD. So we've already stated that for starting at the A end. Now we're going to start with the end that has the D. So CD plus BC equals BD. Since AC and BD are equal to the same thing, we can say they're equal to each other through the transitive property of equality. So you notice both CD plus BC, one time we say it's equal to AC, the next to BD, so we can say they're equal to each other. And the definition of congruent segments, we can say that segment AC is congruent to segment BD, since they're equal to each other. So if you need to, go back and play this over a time or two, and it really helps if you have it written down and the diagram right in front of you. It helps you see what they're trying to prove. Now, time to check your progress. Here's another time you're going to want to draw the diagram in your notes, what is given, and what you're trying to prove. It'll make it so much easier when you're trying to answer the question. So, which reason correctly completes the proof? We're trying to give a reason for why AC plus CY is equal to AY, and BX plus XD is equal to BD. Okay, since AC is equal to BX, and AC plus CY is equal to BX plus XD, we're adding the same quantity. We're adding AC here and BX here to CY and XD. Here's CY, here's XD. To this side we're adding BX, to this side we're adding AC. So in essence we're adding the same quantity to both sides of this equation. So it's the segment addition postulate. We have some more properties for you to add to your properties notes. The reflexive, symmetric, and transitive property of congruence. We've discussed this about equality before. Now we're going to discuss congruence, segment congruence. Also, there's the transitive property of congruence that you need to add to your notes. And make sure that you have the substitution property added in there as well. We've used it before when we're doing proofs, but make sure that that is in your notes somewhere. Okay, we have a real-world example. I'm going to pause and let you read that yourself. You will also want to copy down what is given to prove and draw your diagram. It'll make it easier to follow along. Okay, our statements were given WY is equal to XZ, or YZ, so that means the segments are congruent to each other by definition of congruent segments. Notice that we're listing the rest of what's given. You don't have to list all the given together. You can list it as you get ready to use it. Okay, so now we can say that WZ is congruent to WX, because since they're both congruent to XZ, we can say they're congruent to each other by the transitive property. Now, substitution. Let's look at this a little bit. Since in statement 2 we say that WY is congruent to YZ, and in statement 4 we say YZ is congruent to WX, notice that this one and this one they're both congruent to WZ, so we can say that they're congruent to each other. So, well, they're substituting in. I would have said transitive property again, but anyway, they're substituting in. All right, you can check your progress, so take just a moment to write down what's given, what you're trying to prove, and your diagram. And I do want you to know that there's more than one way to do a proof, because you might see when they're short, there's pretty much, there's only 3 or 4 steps. A lot of times there's only one way you can go about it. But when you start getting into the lengthier proofs, you can go about it several different ways. Everybody's not going to have the exact same answer at the same time. We're going to think things through a little differently. So that's what makes it a little more difficult to teach, a little more difficult to grade, a little bit more difficult to learn from each other, because you think differently. But that's okay. So which choice correctly completes the proof? So take just a minute and study that proof. What did you get for a reason for 5? Did you come up with symmetric property? If you did, that is awesome. If not, why don't you go back and take another look at it to see what you might have, how you might have been thinking wrong, or if you came out with a different way. All right, it is time for you to begin your exercises. Good job, folks.